Hi folks, it's Steve here from analyticsinAction.com, and what I want to do today is talk about the design of simple business intelligence solutions using SQL Server and PowerPivots. So in a lot of my previous posts, I've talked about discrete business intelligence techniques such as various aspects of PowerPivots or integration services and just say database warehousing. But what I want to do today is move up a level and really talk about, I suppose, demonstrate the big picture in terms of business intelligence and basically how these various techniques that I've talked about in the past fit together to provide a business intelligence solution. And I suppose at the core of this, of business intelligence really, is to answer business needs or business questions. So I'll spend a bit of time talking about that. I'll also talk about some of the challenges that businesses face and why, unless you have the right tools and techniques, that delivering these solutions can be quite challenging. Then I'll talk about the individual components, business intelligence techniques that make up a business intelligence solution, and then I'll walk through a sort of a live demo of how all these components fit together to provide a solution. So business intelligence projects result from business needs, and as analysts, we get exposed to lots and lots of questions, and they come from marketing guys, senior management, you name it. They come from all over the business. So those questions generally are about users wanting to understand how to better manage the business. And the hardest sort of decisions to make in a business are generally where you don't have the information to make a clear decision, or there's contradictory information around the business. So these sort of questions that are on the slide, so what is the profile of our high value customers, or how are sales in a particular region for product A comparing to last year, or why is churn increasing, what products are responsible for 80% of our profits. All of these sort of decisions or questions are absolutely crucial to the day-to-day running of a business, and that's where business intelligence comes into play. It's about using data to drive insight and using that insight to enable a business to make better decisions. And you'd think that it would be becoming easier for businesses to make decisions. The volume of data out there is increasing significantly. There's a ocean of data there. There's social media, there's web search information, there's CRM systems, there's transactional databases, there's leads databases, there's access databases sitting on sales guys' computers, there's Excel files all over the place. And you'd think because of the amount of information being stored, it would be much easier for businesses to make really, really good decisions. However, this volume of data is causing a lot of problems in itself. IDC in a recent report suggested that the volume of data was going to increase something like 44-fold over the next 10 years. In addition to just the sheer volume of data, you've got the data is becoming more and more diverse. So the end result is that businesses have a number of data challenges that makes it difficult for them to answer a lot of questions that they should in theory be able to answer. So there's four key ones as I see it. Data exists in silos, so essentially exists in separate systems that aren't interlinked, so you can't see the big picture or the integrated view. There's data quality issues, so things as simple as duplicate records within a system or missing records. And then there's, as I mentioned before, the volume of data. And then from an analysis perspective is, because data is coming from so many different systems, it's so diverse, it becomes very multi-dimensional. There ends up to be so many columns of data that traditional analytical techniques can't actually find trends and patterns that the business needs to know about. So these business challenges lead to what I see as a really poor allocation of of resources within most businesses. The vast majority of time is generally spent trying to integrate and clean up those various data sources. So linking, say, the CRM system to the transactional database and getting rid of duplicates. And all of this sort of data integration and data cleansing work needs to be done before any reporting is done. And typically, most businesses spend a disproportionate amount of time on the data integration. This leaves them less time to focus on reporting, so actually reporting on what's going well within the business and what's going wrong. So that means that even less time is left at the top of the pyramid here to actually proactively go out and, say, fix the parts of the business that aren't working, and perhaps amplify the bits of the business that are working well. So this leads to sort of what I see as a bit of a resource allocation paradox. So very little of analyst time is really spent doing the things that really adds value to the business. So, while many businesses do have this resource allocation paradox and allocate a disproportionate amount of time to these low return on investment tasks, by the use of really smart business intelligence technology, it's possible to flip that triangle upside down and allocate more resources to the high return on investment tasks. And basically that's what this presentation is about, is how to link together the various business intelligence technologies to enable improved resource allocation within the business. So getting analysts to spend more of their time working on the stuff that's really going to matter to the business. A generic business intelligence solution can be considered to have, I suppose, six core components. The first is really about cleansing, transforming and integrating these data silos together. In business intelligence terms, it's often known as an ETL process, so an extract, transform, load process. So the information is getting extracted from multiple systems, it's getting transformed into a suitable format, and then it's getting loaded into a destination. That destination is the next box here. It's the data warehouse. So a data warehouse is essentially a database that's designed to enable reporting and data mining. From the data warehouse, the data can flow into reports, scorecards and dashboards. So that enables a business to identify areas of under or over performance. So for example, identify whether churn's increasing or revenue is declining. Once you've actually identified parts of the business that are either under or overperforming, the next logical step is to actually do what we call root cause analysis. So understand why, for example, those customers are churning. What is the profile of them? And once we actually understand that profile, we can then do work such as predictive modeling. That allows us to do strategic targeting, target for example, the customers that are most likely to churn with some sort of proactive campaign, which will keep them, which will enable the business to retain them. Often with the strategic targeting, particularly with predictive models, you can actually test several different models. And if you do that, the logical next step within this BI circle is to evaluate which one of those models or campaigns were the most effective. The idea is that you can then continue on doing what has the best response rate and kill off perhaps the campaigns that are less effective. And that pretty much completes the circle. And the idea with this circular sort of feedback process is that it enables basically continual improvement within the business. So continually driving down, say, churn, continually driving up revenue. What I'll do now for the rest of this post is basically go through each one of those steps and give you a practical demonstration on how it works and the specific techniques that's used. Okay, so the first of the 6 steps is involves integrating, cleansing and transforming the data. So you're extracting, when I talk about integrate, you're extracting data from the source systems, you're linking those systems up, you're transforming it into a format in which to you can easily report on it, and then you're loading it into a data warehouse. In business intelligence terms, this is known as ETL, so extract, transform, load. So you're extracting out of source systems, you're transforming it, and then you're loading into a data warehouse. And as for sort of a practical example, there are a number of these ETL tools around which perform this process. One of the tools I use is SQL Server Integration Services. It's part of the SQL Server suite, and as an example, what I'm doing here is I'm pulling data from from the sales database. This is a SQL database. Then here I'm extracting it out of from an Excel sheet which was exported from a CRM system. I've also got a connection to a Microsoft Access database, but the reality is you can connect to pretty much any sort of system, and once you've got the connection to those systems, you can then run through a number of different transformations, such as you can standardize the perhaps the number formats or name formats, in order that the data from the various systems, when you join it together, it all is in a standardized format. You can do things like tag names in a CRM system, customer names as whether that customer is churned or whether they're still an active customer. You can do other things like calculating the days since that customer was last active, such as the last purchase they made. You can also do things like send perhaps customers with missing data associated with their name off to a particular file, such as here we're sending off to the data quality team, so they can actually look into that missing information and see whether they can supplement it and correct it. So that's sort of the cleansing process. And then finally down the bottom, after some more transformations, such as tagging customers with no activity for 4 months as being churned, we do the actual load process. So extracting it out of these source systems, we're transforming it, we're cleansing the data, and then loading it into a data warehouse which is structured in a way to enable easy reporting. And you can, with these ETL processes, the normal sort of thing you'd do is you'd actually build it so it's totally scheduled. So perhaps on the first day of the month, when all the data the databases are up to date, you might set it to run at 3 o'clock in the morning, and it'll process it, then load it into the data warehouse. But you can also just trigger it manually. Here I've got a little run button, so this will then process the data. The data will go yellow and then green as it passes through each of the transformations, and then ultimately it gets loaded into the destination data warehouse. Okay, so the second of the 6 steps is to store the data in a data warehouse. So the idea behind a data warehouse is that it contains cleansed data. There's a single view of the truth, so that particular columns will have very, very clear definitions. So for example, the definition of a churned customer might be, they haven't purchased for perhaps 4 months. So once you've got data into a central data warehouse, you can very clearly define the various columns. So that's a really important part of a data warehouse, because what you find in a lot of businesses, people will often end up arguing over different data, and ultimately you find out that the data has different underlying definitions. So it becomes much easier if you have a central data warehouse, very, very clear definitions, and all the reporting runs off that. So in a sense, there's a single view of the truth. And the idea is that data warehouses are structured so that they're if the data is in a suitable format to report, and it's highly accessible. So a lot of traditional sort of relational database systems tend to have information smeared across multiple tables within a database. Data warehouses often have a much simpler sort of structure, and it's much easier to access that information. So for example, a data, actually I'll just talk about a little bit about data warehouses. Data warehouses are often associated with OLAP cubes and multi-dimensional databases. But the reality is, a data warehouse doesn't really need to be multi-dimensional, so to speak. It can just be a flat a flat table, so it doesn't need to sit on top of OLAP cubes, and that's what I've got here. I'll just show you a very simple data warehouse that I've got. So it's just the sales table. So this is the result of that ETL process that I just run. So I'll just select it here. So this is the information here. So very, very simple form of data warehouse. No OLAP cubes running here. And the sort of interesting thing is that with some of the technology that's being developed these days, particularly columnar databases, which makes querying the information much more much quicker. I tend to think that in some instances you don't really need OLAP cubes. So it'll be an interesting sort of to see over the next couple of years how the progression of database technology actually influences how often actually OLAP cubes are used. But in this sense, just a flat table containing information around telco customers, how many megabytes they've used, their average revenue per user, where they're located, whether the customers churn, the products held, and how long they've been with the company and in the segments which they belong to. So that's a very simple data warehouse. Okay, so the third of the 6 steps is about reporting. So reporting is can be used in a fairly broad term, so it may include the standard reports, scorecards, dashboards, you name it. But the goal is to really identify areas of over or underperformance within the business. So this is just an example of a basic scorecard for a telco. So it has information such as the total data usage for its broadband customers, the churn within the customer base, the average revenue per user, the lifetime value of the customer base, the average tenure of the customers, and the product holdings, all by the last 3 months. So here's what the scorecard looks like within a PowerPivot, and what I'll do is I'll just sort of show you some of the features of a nice scorecard. And really what you want to do within any sort of reporting tool is be able to drill down and understand trends and patterns within the data set. And a good example of a reporting tool or a dashboard is Microsoft's PowerPivots. It's a add-in for Excel. It has a couple of pieces of technology in the back end which really, I suppose, makes it stand out from perhaps some of the other reporting tools. So it has a columnar database in the back end, so this compresses data up to tenfold, makes it much easier to deal with data files just because of the smaller size. And it also has an OLAP cube in the background, so they've taken the OLAP cube functionality out of SQL Server Analysis Services and really dropped it in the back end of Excel. So take something that's really can be quite complex, which is multidimensional modeling or OLAP cubes, takes it out of and basically makes it much simpler by throwing it in the back end of Excel. So what this allows us to do is to slice and dice data very efficiently. So we've got this these views which I've just explained, and by having an OLAP cube in the background, we can look at particular components of the slices of the data set. So we can, for example, we can just click on the slice up here, the consumer one, and all the and what will be shown is just the consumer part of the business. And if we then clicked on, for example, consumer in Perth, we'd see that we get that view of the business. And out of interest, we see that churn is very, very high in that part of the for consumers in that part of the country. What we can also do is group particular segments or parts or particular slices. So now we've grouped consumer and enterprise together. So it really just gives you this an amazing ability to slice and dice incredibly large volumes of data. I've seen 200 or 300 million rows of data be loaded into the back of these PowerPivots, and it's really that cool technology, the columnar databases and the OLAP cube technology, which has been taken out of Analysis Services and thrown in the back end of Excel and simplified. That makes it such a cool tool. It's also very quick to build these scorecards. So a scorecard like this could be built within perhaps half an hour, very easily. So very cool tool. Okay, so the fourth step is root cause analysis and strategic targeting. So what we saw in the last slide was churn was much higher in October, and it also appeared to be a bit higher in Perth. But what we really want to do is understand the root cause. What are the underlying factors driving this churn, and really what is the profile of a customer that is churned. And once we understand what that profile is, we can then target those customers and perhaps stop them from churning. So what we can do is we can use techniques such as what do we have here? So techniques such as decision trees to really help us understand what is driving churn within the customer base, or in fact almost any sort of behavior within the customer base. So if we look at all of the customers, so all 8,000 customers in the data set, we see that of those 32% churned over the period. But if we look at those in Perth, 56% or almost 57% churned. But when we drill down even further and look at other factors that weren't included within the scorecard, such as the amount of data that those customers were using, we see that churn was the highest in the high usage customers. So if they're using more than 7.4 gigs of data, all 328 customers had within Perth had left us. And if we're in the next tier down, we see that almost 97% had left. So this technique allows us to build a really clear profile of those either a problem areas such as churn, but the interesting thing is you can also turn it around and look at areas of the business that are overperforming, such as sales. What is the profile? Why are sales up in a particular region? It may be a particular SKU within a particular store in a particular region, and these root cause analysis techniques allow the beauty about them is it allows us to analyze multi-dimensional data, so data in which there are huge numbers of combinations of factors that could be influencing the outcome, such as churn or increase in sales, and identifies real hotspots where that behavior is either very high or very low, such as what we've seen here. Once we've actually identified that the root cause of the problem, it then enables us to build predictive models. Once we have predictive models, which basically identify the profile of the customer exhibiting their behavior, we can then apply those predictive models against other customers within our data set and understand what is the probability that they will exhibit that behavior as well. So the interesting thing is that when you actually understand what is the profile of customers using this exhibiting the behavior, you can then use your market intelligence to actually, I suppose, join the dots. So for example, in this case it turned out that a competitor was offering a very cheap data plans for customers who used more than 5 gigs of data within a month, and this was a local provider that only provided that offer within the Perth region. So once we understand this, we can then basically apply predictive models. So we know what the profile is of customers who have churned, so we can then look at customers with that profile in our existing customer base and apply basically that profile against those customers and basically predict what is the probability that those customers are likely to churn, and then we can target just those customers that are likely to exhibit the behavior that we want. And this allows us to become very, very targeted and very, very cost effective in terms of our outbound marketing campaigns. Once we have a predictive model that basically applies a response rate probability to each customer, we can take that information a step further and predict the likely profitability associated with the campaign. So once we have that model, we know who is likely to respond and who's unlikely to respond to a campaign. And if we have inputs such as the fixed cost associated with the campaign, so essentially the cost to set it up, the target population size, the individual cost to actually run that campaign per user, and the likely probability or likely the likely revenue we'd gain from a positive response, such as stopping a customer churning. Those inputs allow us to basically model what proportion of the population we should target, and in order to maximize profitability. So in this case, with these inputs and the predictive model, the churn model we previously described, the optimal proportion of the population is about 70 odd percent or 75%, and in this case with these inputs the profitability would max out at about $85,000. And if we went on and contacted a higher proportion of the population, the actual profitability would drop off because the customers we end up contacting are ones that are unlikely to respond. So the fifth and final step in this BI circle is really campaign evaluation. So once you've built a predictive model, you've run a campaign, you really want to look back and evaluate how it went. The basic philosophy is, if something works, you want to do more of it. If it doesn't work, you need to evaluate it and fix it. So the typical sort of process is to have a control group. So a control group can be set up in a number of different ways. It may be, for example, just a random proportion of the population that was contacted, or it may be, say, the existing methodology for contacting customers, and then you compare it against your your new model. So for example, the model that we built was a decision tree type model. We use one model, but you can use a number of different models. So for example, another technique could be, say, a neural network. You can compare those two modeling techniques against a control group, or if you want to get more advanced, you can actually use what you call ensemble or composite models, where it's combining model A and model B, so the best parts of model A and the best parts of model B, and see what the response rate is there. So that pretty much closes the loop. So just to recap, starts with basically cleansing and integrating the various data sources, putting it into a location where you can easily report on it, running reports and scorecards, identifying areas or aspects of those reports and scorecards that are of interest, and basically identifying the root cause of the either underperformance and overperformance, then targeting those areas that are of interest to you. And then once you've done the strategic targeting, to basically evaluate how the targeting worked, and amplify the stuff that did work, fix or cull off the stuff that didn't work, and that allows you to then restart this whole circle again. The idea is that you end up with a continual process of improvement. Okay, so that's pretty much my summary of designing simple business intelligence solutions. So if you found this useful, it might be worth either taking a look at my website or subscribing to my YouTube channel. So my website is here, it's analyticsaction.com. So I have lots of information around data integration. So the first, what we talked about, integrating and cleansing data. We've got lots of stuff on reporting, so things like reporting services, PowerPivots. We've got stuff on modeling, so that's like the decision tree model that I showed you, and just analytics in general. So there's lots and lots of resources there. And the other option too is to come across and just subscribe to my YouTube channel. That way you'll get updates every time I produce another video. So I hope you found this overview useful, and yeah, definitely come across and have a look at my website.